We have a man walking away from a lamppost. That lamppost is 15 feet high. The man is 6 feet high. And we know that he's walking away from the lamppost at a rate of 5 feet per second. I define the distance from the man to the lamppost as y. Therefore, that's a positive rate of change because the value of y is getting bigger. And then I defined x as the distance from the tip of his shadow to the lamppost. And so in part A, we're calculating the rate of change of the tip of the shadow away from the lamppost as dx dt, and we want to know what that value is when y equals 10. So initially, this would seem like this is a Pythagorean theorem problem because I've got a couple right triangles staring me in the face. However, it's actually a similar triangle problem. And again, you can do this a lot of different ways depending on how you define the variables. This is how I set it up. And so comparing these things, I realize I need this distance here. And that distance there would be defined as x minus y. Okay, I don't want to create another variable because that's going to create more hassles for me. So I'm just going to keep it nice and neat there. Therefore, my equation becomes a similar triangle setup. The height of the man over the height of the lamppost is equal to the length of the man's shadow over the length of the shadow to the lamppost, which would be x. Now, I could take the derivative at that point, but that would be ridiculous because if I do a little bit of Algebra 1 early on, I can simplify this quite a bit to get something like the following, which would give me 15y is equal to 9x. Okay, I like all positive leading coefficients, so I move things around there. Now I can even make it simpler, and I'm going to solve for y. So y is equal to 3/5 x. That is a nice, easy formula, and it's easy to work with. The derivative, running out of space here, will come up here. The derivative of that would be simply dy dt is equal to 3/5 dx dt. And we know that what dy dt is. Dy dt is 5. Plug and chug. And we get dx dt is equal to 25/3. And that would be feet per second. Okay. Now, moving on to part B, it changes a little bit, and part B wants to know what's the rate of change of his shadow. In other words, like it says here, what's the rate of change of the shadow? And we define the shadow as dx dy. So if we look at this as taking the derivative with respect to y of x minus y, we get something as simple as dx dt minus dy dt will give us the value that we're looking for here. We know what dx dt is from we know both of these answers from the original problem. We know that dx dt is 25/3. We know that dy dt is 5. And when we do a little bit of math there, we get 10/3 feet per second. If you want to convert that to a decimal, you can, or you can leave it in fraction form.